space. Going there. Okay, I love you.
The command and data handling subsystem has two parts. The flight computer was designed by last year's senior design team. The software is still in development. The software interfaces with the rest of the components of the CubeSat. It transmits the pictures that the camera takes back to Earth. It decrypts communications that the satellite receives from the ground station, and it monitors the various gauges, including the battery, temperatures, accelerometer, and gyroscope. The flight plan for our CubeSat has been developed, and the command and data handling subsystem is building the realization of this flight plan in software. This is what the flight plan looks like. These first boxes, in blue, represent the startup routine that runs every time the CubeSat is powered on or restarted. The big green section in the middle represents the supervisory functions. These determine what the satellite should be doing at all times, including how to handle commands from mission control. Finally, on the far right, is the set of major functions that the satellite needs to handle. The CDH subsystem has taken this flight plan and broken it up into key software components. One of the most important methodologies that we've been following while working on this software is pair programming. By working together to accomplish all of the tasks, we can much more easily bounce ideas off each other and make more consistent progress. The rest of the software still needs to be written and tested. We will be providing a software requirement specification document, or SRS, as well as a timeline that will facilitate future progress. Development will have to continue with the low-level drivers, on top of which we can program the autonomous functionality and supervisory functions. Along the way, we will have to make sure to test everything that's written. There are a couple things that you need to know for developing the software from now on. First is how to set up the programming environment. We have written a guide that details how to do this. An important part is installing the development libraries for the microcontroller that we are using. We also have plenty of documentation for all of the integrated chips on the flight computer board. An important process to follow for the software development is test-driven development. We've written many test cases that the software will need to account for. By using these test cases, we can design software that is functional. One thing we wish we had known before spending a lot of time on this project this semester is the existence of the SolarisWare driver library. This library provides most of the low-level drivers that we need to communicate with our onboard hardware. Recently, several members of the team went to the CubeSat conference in California. They met many other like-minded groups that may be great resources to collaborate and share ideas with.